Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. Your one stop for learning all those interesting concepts and short tricks which are useful to crack the competitive exams and obviously the school exams. You become smarter when you learn such amazing concepts, and one of those amazing concepts is in the class 6th NCERT book. I'm going to take this up very elaboratively, and so that you can understand, because in NCERT they have given the concept but they have asked a lot of questions. So this is a research based video exclusive on YouTube, and you will realize the depth of this topic when I complete the video. So you need to watch the complete video. If you are a mathematics teacher, this is wonderful for you. I tell you, when you watch this and tell it to your students, it will be like, they'll start thinking about the numbers, and that is what is the intention of that chapter, number play. The concept which I am going to take up is the concept of supercells. Now I'll tell you what are supercells, and we are going to crack the rule for identifying the supercells in a given grid. So let's see what is the concept of supercells. To understand the concept of a supercell, you first need to draw a horizontal table like that. This is a 4-cell table and this is a 5-cell table. So let's put some numbers in each cell. Then I will tell you what is a supercell. These are all cells. Out of these, some of them will be termed as supercells. Let's write 28 inside this, 74 inside this. Let's take 92 here and 114 here. And similarly in these 5 cells, let me write some numbers: 192, 214, 163, and then we have, let's say, 200 exactly, and then 104. Out of these numbers, let us identify a number whose adjacent numbers or the neighbors are smaller than them. Like this 28 has only one neighbor, 74, but its neighbor is greater. So this is not a supercell. 28, that cell is not a supercell because the neighbor is greater than 28. Likewise, if I consider 74, let us check this. On the left hand side, the neighbor is 28, which is smaller than 74, and on the right hand side, the neighbor is 92, which is greater. So even if one neighbor is greater, that cell will not be a supercell. Let's try 92. On the right of 92, I have 114, so 92 is also not a supercell. But if I check 114, it has only one neighbor, that is on the left hand side, and that neighbor has a smaller value, 92, and therefore this cell 114 is a supercell in this grid, and there is only one supercell in this grid. But can we write only one supercell? Let us check using 5 numbers here. Now if you take them one by one, 192 has a neighbor which is greater, so this is not a supercell. 214 has, on the left hand side, it has 192 which is smaller, and on the right hand side 163 which is smaller. So both the neighbors of 214 are smaller than 214, and therefore this becomes a supercell. Likewise, if you take 163, the neighbors are greater, so this is obviously not a supercell. How about 200? On the left 163 is smaller, on the right 104 is smaller. So yes, 200 is a supercell. And finally 104 has only one neighbor on the left, 200, and therefore 104 is not a supercell. So there are 2 supercells out of these 5. But can we write a rule through which we can identify how many supercells will be there in a particular grid? So for this video, I am going to take only the horizontal row. That means the row, it might contain maybe 3 cells, 4 cells, 5 cells, or even 10 cells. Can we find out a rule how many supercells are there in that particular grid? Suppose I'm taking one more example. Let's take a series of numbers where we have 31, 46, 28, 17, maybe 24 and then 63. How many numbers are there? These are 6 numbers, right? Let's take one more. If we take 104 on the left. Now, is this a supercell? Because its neighbor is smaller, therefore it is a supercell. Is this a supercell? The neighbors are larger? No. Is this a supercell? The neighbors are smaller? Yes. This one, neighbor is larger? No. This one, neighbors are larger? No. This one of the neighbor, this one is larger, so no. And how about this one? Neighbor is smaller, so yes. There are 1, 2, 3 supercells in this particular grid. Now, I hope you have understood what do we mean by supercells. Now, let us try to crack the logic. Let us start with the first very basic thing. Before that, I must tell you about this short tricks ebook which we have brought out very recently. This is for quantitative aptitude, to understand 24 different topics of quantitative aptitude through 300 different short tricks, and all those will prove to be a boon for your preparation because they are going to enable you to calculate 10x faster in terms of your calculation speed. And what more, we are giving away the reasoning course also along with this quantitative aptitude ebook. Very nominal costing ebook. So many exams can be targeted if you want to study through this. Do send me a message on WhatsApp 9896369963. That is the WhatsApp number on which you need to send me a message to get a copy of this amazing combo. So now let's see what we have in a 2-cell row. Here we have a 2-cell row. So we need to understand that in a 2-cell row there will only be 2 numbers, and whenever there are only 2 numbers, what is going to happen is there will be only one supercell because one of them will be greater than the other. So if I write this as say 36 and 18, this is the supercell, this is not the supercell. But if I exchange it like this, 18 and 36, this will become the supercell, this will not be the supercell. So in a 2-cell row like this, there will be only one supercell, a maximum of one supercell. Both of them cannot be supercells. Likewise, if you have a 3x1 grid here, now you can see all 3 of them can be a supercell if I want only one supercell to be there among these 3. One supercell. How? Let us check. Either the first one can be a supercell and these 2 will not be supercells. Suppose I take an example of 117 here, 63 here, and maybe a smaller number like 50 here. Now only one supercell is there. Now this can be shifted here, exchange, then this will become the supercell because that will contain 117, and the same 117 can be shifted here also. So this will become the supercell. So there may be a case that there is only one supercell, and this can be done in 3 different ways because that particular supercell can be any one of these 3. So 3 different ways in which I can obtain a single supercell among a 3x1 grid. Likewise, if I want 2 supercells here, how do I get 2 supercells? See, the neighboring cells cannot be both supercells. Now suppose this one is a supercell, then this will never be a supercell because its value is less than this. So this can be a supercell. So if we want to have 2 supercells in a 3x1 grid, this can only be done in one way. That is, the first and the third have to be larger than the middle number. Like you can take 41 here, say 65 here, and 74 here. Now you can see this is a supercell because the neighbor is smaller. This is a supercell because the neighbor is smaller. So 2 supercells can only come in only one way. Likewise, if you have 4 cells. Now we need to understand one very important thing, that even in a 4 by 1 grid, if you want to have only one supercell, it can be done in all 4 ways. Take the largest number in one of the cells and rest all 3 numbers which are smaller than that. Maybe like say 52, 63, 85 and let's take 23. Now see what happens here. Out of all these, only one is a supercell. Now if I shift 85 to some other position, which I can do here, here or here, I will get 4 ways in which I can get a single supercell. Now how about 2 supercells? Now if I want 2 supercells in these 4 cells, just like here there was only one way, now here I can have the greater numbers, that means supercells in different positions, like first and third cells. This and this can have the higher numbers, or it can be like second and fourth position. Second and fourth, they have to be alternate, because if they are not alternate, they cannot be adjacent. We can put it up that way. They can never be adjacent, because one of them will be greater than the other, so other will be smaller than the first. So 1 3 and 2 4. Is there any other combination which works? If these two are supercells, these will never be supercells. And if this and this are not supercells, then these two can be supercells, right? So how many possible ways are there? Only 2 different ways in which we can have it. Now, can you find out the third one? Are we missing out on something? Yes, you got it right. How about doing a 1 and 4? Can this be a possibility? Let's check one result. 236, 63, 84 and 192. How about these 4 numbers? Here we have a supercell because its neighbor is smaller. This cannot be a supercell now. This, is it a supercell? No, because its neighbor is smaller. And how about the last one? It is a supercell because its neighbor is smaller. So 1 4 also works. Now this is the way we need to find how many possible combinations are there in a particular grid. So a 4 by 1 grid can have one supercell in 4 different ways, can have 2 supercells in 3 different ways. That is, 1 and 3 can be supercell, 2 and 4 can be supercell, or 1 and 4 can be supercell. 3 different combinations work. Now if you are getting this, now comes the challenging part. What happens when the number of cells in the row increases? Here you can see we have 5 cells now, and when it comes to 5 cells, we can have 1 supercell, we can have 2 supercells, or we can have at most 3 supercells. Now let us see in how many ways can we get these supercells. Now when we talk about 5 into 1 grid, 1 supercell means it can be any one of these 5. I can put the greatest one anywhere and then rest all will be smaller. So 5 ways in which I can get a single supercell in among these 5 cells. Likewise, if I want to get 2 supercells, now let us see the combination. This is one. This is number. I am numbering the cells. Okay, 1, 2, 3, 4, 5 number cells. So if I want 2 supercells, I can have 1 and 3 as one combination. How about 1 and 4, 1 and 5? These are all combinations with 1 as one of the cells. Then 2 and 4 can be a supercell. Then 2 and 5, that can be another possibility. And we are left with one more, 3 and 5. That is the last combination. Now you will not be able to find any other combination which works like this. 1 and 3 will have the neighbors greater than itself. 1 and 4, 1 and 5, 2 and 4, 2 and 5, 3 and 5, all these are supercells. Now if I want 3 supercells, see, adjacent cannot be supercells, right? So I cannot start with 2 and have 3 supercells. 2, 4, 5. 4 and 5 will become adjacent. 2, 3, 4, they are already adjacent. So what is the possible combination? 1, 3, 5. See, 1, 3, 5. They can be supercells. So I can put some numbers here and show you how 1, 3 and 5 will work. Let's take one example. Here let us take 124. How about this becoming 84, 91, 63 and say 96. Now check 1, 3 and 5. Are these three supercells? And you will realize that yes, its neighbors are smaller. Its neighbors are smaller than this, and this has a smaller neighbor. So only one combination works when there are 5 by 1 grid and we have three supercells. Likewise, now comes the challenging part. Now, if I have a 6 by 1 grid like this, I can have one supercell, I can have two supercells, or I can have three supercells. Now, why I say three supercells? Because half of 6 is 3. So I cannot have alternate cell supercells because half of them is 3 only. 6, the half is 3. So one supercell can be among all these. You can have any one supercell. So 6 ways of having a single supercell, right? Two supercells is the most tricky part. Then we will check with 3 also. How about 2 supercells? Let's start with the first one. So first and third, this can be one combination. How about 1, 4, 1, 5, 1, 6? All these combinations, they work. Now coming to 2, I can't have 3. 2, 4, 2, 5, 2, 6. All these also work. Now starting with 3, 4 cannot be a possibility. 3, 5, yes. How about 3, 6? Yes. Then starting with 4, I can only have 4, 6. So how many possibilities? There are, just like here 2 supercells had 6 ways of writing the 2 supercells. Here writing the supercells, which are 2 in number, is done in 10 different ways. And now coming to 3 supercells. Remember the rule? The rule is really important because you need to understand that adjacent ones cannot be supercells. 3 supercells. Let us try. How about 1, 3, 5 alternate ones? This is working. How about 1, 3 and 6? Still no adjacent ones here. Now 1, 3, I am done with that. So let's start with 1, 4. With 1, 4 I can have 6. That will not also be adjacent. And finally the evens, that is 2, 4, 6. They can also be supercells. So I can put one of these here and show you. So let us take a case where 1, 4 and 6, they are supercells. 1 is a supercell, so 96. So this has to be smaller. 2 is not a supercell, so 72. 3 is not a supercell, so how about taking 63? That is also not a supercell. 4 is a supercell, so maybe 100, right? And since it is a supercell, it will have a smaller neighbor, so maybe like 52. And 6 is a supercell, say 218. Now you can check. This is a supercell, this is a supercell, and this is a supercell. See how many different combinations work. So for 3 supercells like this, you can have 4 different combinations or 4 ways of obtaining 3 supercells in a 6 by 1 grid. Likewise, if you have a 7 by 1 grid, now 7 by 1 grid will get even more trickier. In a 7 by 1 grid, you can have one supercell in obviously 7 ways. Now the 2 supercells, this you have to make a lot of combination. 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 2, 4, 2, 5, 2, 6, 2, 7 like that. And you will find that there are 15 ways of getting 2 supercells in a grid of 7 by 1. Likewise, if you want to get 3 supercells in 7 by 1 grid, you will have 10 different combinations, just like we had 4 different combinations here. And finally, you can even have 4 supercells. 1, 2, 3, 4. That is the only way, that is one way in which we can get 4 supercells in a 7 by 1 grid, which is 1, 3, 5, 7. Now, what we need to understand here is, what is the rule? Are we doing all trial and error here, or are we trying to get into, that kind of frame of mind where if we are given a 13 by 1 grid, we'll be able to find how many supercells will be there maximum, and if we want 4 supercells among those 13, then how many possible combinations are there? Now for that, you need to understand this table which we have here. Now you can see in this table we have given 2 different things. One is the number of cells in a row. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 15 we have taken, and these are the number of supercells. 1, 2, 3, 4, 5, 6. I already told you up to 7 we have done. So in a 7 by 1 grid, 1 supercell can be done in 7 ways, 2 supercells in 15 ways, just now I told you, 3 supercells in 10 ways, and 4 supercells in 1 way. We cannot have more than 4 supercells in a 7 by 1 grid. So whatever we did till now in the video, we have summarized it already here in this table. Now let us generalize this. Can you see the first row? If we have a 8 by 1 grid and we want to have 1 supercell, then look at the trend, 2, 3, 4, 5, 6, 7, it will come out to be 8. And likewise, if we have a 9 by 1 grid, it will be 9, 10 by 1 grid, 10, 11, 12, 13, 14, 15, this is going to continue. So 1 supercell is very easy. Having a single supercell is like having total number of cells in the row. Now, the tricky part, the 2 supercell concept. In a single cell, obviously there will not be anything which contains 2 supercells. You can't have 2 from 1. 2 from 2, both of them cannot be supercells, so this is 0. 3 by 1. So 3 by 1, I hope you understand, 3 by 1 is this, and 2 supercells. So it can be first and third only, so therefore only 1 is here. Likewise, we did 4 by 1 grid having 2 supercells 3 times, 3 different ways of representation. Then 5 by 1 grid having 2 supercells 6 different ways. Likewise 10 different ways here, 15 different ways here. Now I want to find how many different ways can we make 2 supercells in a 8 by 1 grid. So for that we need to understand the progression here. 1, 3, 6, 10, 15. Now if I see 1, 3, 6, 10, 15 and I want to find the next number, see the differences. This is 2, difference is 3, difference is 4, difference is 5. So I hope you understand now. What will be the next number? 10 plus 5 is 15. So 15 plus 6, 21. 21 plus 7, 28. 28 plus 8, 36. 36 plus 9, 45. 45 plus 10, 55. 55 plus 11, 66. 66 plus 12, 78. 78 plus 13, 91. See how comfortably we are getting the number of supercells as 2. So suppose somebody asks you, there is a 13 by 1 grid, 13 by 1 grid, and we want to have 2 supercells. In how many different ways can you mark those supercells? 2 supercells. It is 66 different ways through which you can mark those supercells. Lot of use of permutations and combinations, but at class 6 level you need to observe the number patterns. So let's see the next row. Having 3 supercells starts with 5 by 1 grid, because below that you can't have 3 supercells. So 1, 4, 10, and now I need to observe what is the pattern, and you will see that the pattern which comes up is So 1, 4, 10 is already there. After that you will have here 20. So I am just giving you the pattern, then I will show you how the pattern has been obtained. 20, 35, 56, 84. And if you want to have 4 supercells, it starts with a 7 by 1 grid in one way, and then after that we will move on to 5, 15, then we have 35 and 70. These 4, and likewise it goes on and on, for a next one, then like 8 by 1 grid having 1, 2, 3, 4, you can have different numbers written like this here. Now apart from all these things, see, 8 supercells, 8 by 1 grid having 5 supercells is not possible. 8 by 1 grid having 5 supercells, not possible. So 9 by 1 can have 5 supercells. So it will start with a 1 here, and likewise you can't have any numbers here, and you can generalize it now. So I have done it for you. After 84 also we have the numbers, and the numbers after 84 come out to be, this is 120, this is 165, this is 220, and this is 286. See, 15 by 1 grid, and you want to mark 3 supercells, it can be done in 286 ways. Now, how did I obtain all those things? Obviously, I did not try so many combinations, which is impractical. I will tell you the rule. After that, for the 35, 70, we have 126 here, and then 210 here, and then 330 here, and finally 495 here. So let us try and understand up to 2, I think 1, 3, 6, 10, 15, we already did this rule. How about this? 1, 4, 10, 20, 35. 20, 35. So what did I observe to get the next numbers? The difference here is 3. The difference here is 6. The difference here is 10. The difference here is 15. Take the difference once more. This difference is 3. This difference is 4. This difference is 5. Now can you observe the pattern? And can you go in the reverse way now? Next difference will be 6. So 15 plus 6, next number will be 21. So what will be the number here? So let me just erase this for you here. So what will be the number here? 35 plus 21, that gives me 56. And where is that 56? Here we have the 56. This number, here we have the 56. Now similarly we can obtain the next one. We have the 7 here. So 21 plus 7, 28, and then 56 plus 28 gives the next number 84, and you can continue this pattern. Likewise, if you want to see this one also, it will have a very, very amazing pattern here also. 1, 5, 15, 35, 70. 1, 5, 15, 35, 70, 126, and so on. How did I get this? I tried only 3 or 4, and then I got the remaining ones using the rule. So this is 4, this is 10, this is 20, this is 35, this is 56. Likewise, so I can try one more time. This is 6, this is 10, this is 15, and this is 21, and one more time. This is 4, this is 5, this is 6. See, just like you were getting the natural numbers here, here also the difference is there. So here first difference only got you the natural numbers. Here the second difference got you 3, 4, 5, 6, 7. Here the third difference got you 4, 5, 6. So as you progress through this table, this process of getting the common, the difference which is more identifiable to get the next numbers will become little more complicated. So for this video, I think we can understand these rules and try to make maybe up to a 8 by 1, 9 by 1, 10 by 1 grid, and try how many combinations work. So like if you do a 9 by 1 grid and you want to have 3 supercells, so you need to understand that there are 35 different combinations through which you can get 3 supercells in a 9 by 1 grid, and that itself is a task, you know. So understanding the rule is more important, and the trial and error can be done for smaller values, like up to these values you can do the trial and error, but beyond that, if you know the rule, you know all the values. So friends, a very important concept for the class 6 students, because this has been adopted from the class 6 NCERT, and supercells is given as one page in NCERT, but it asks you to crack the rule and study the interesting properties. Whatever I told you in this video is not complete. We can observe this table and get to so many different rules, and so many different patterns will be observed in that table. So I want you to explore that and let me know in the comments below, did you like this video and did you find some more patterns? And please share this video with all the CBSE students, you know, who are at present studying in class 6, 7, 8, so that they can build up the aptitude. Do subscribe the channel and share it with your friends, and don't forget to click the bell shaped icon to get all the notifications on the channel. Thanks for watching this video. Look for one more part of the supercells video, in which I'll be taking up multiple rows grid and finding out how many supercells can be drawn in that particular grid. All the best.